Hello and welcome back for more office hours with Bill Jennings at Klamath Community College Distance Learning. We are in video 3 of 5 on talking about solving quadratic equations, and what we're going to talk about right now is solving quadratic equations by the square root method. Now these ones kind of sneak up on us every now and then, and if we can identify the square root method quickly, we're going to have a problem that is going to be over very fast for us if we can identify it. So what we want to be able to do first off is we need to make sure we have a quadratic equation. Once we know we have that quadratic equation, what we want to be looking for is something that very quickly can be turned into the form of something squared equals a number. And it could be that this is a binomial that's squared, some kind of an algebraic expression squared equals a number. And then we're going to apply the square root method to it. And we're going to basically square root both sides of that equation to make it come out. So our steps, we want to be able to manipulate. Sometimes there's a little bit of algebraic manipulation, and sometimes it's just right there, right in front of us, that we can do it. But if I can manipulate it quickly to be of this form, then I can then take the square root of both sides, remembering that when we take the square root of both sides, there's an absolute value problem when a variable is included in a square root. And so that absolute value is resolved by the fact that we put a plus or minus with the square root on the opposite side of the equation from the variable. So I would end up with a plus or minus radical sign that results from that. You should have seen that before in the past. The other thing is, if I have a negative inside the radical, that's okay. I'll get imaginary roots, and so we're just going to have to live with those. One thing to note maybe is that when you do have a negative inside the radical, you'll get an imaginary root, and you won't get a single imaginary root. You'll get two of them, because the plus or minus out front will make it plus or minus this I value that will be there. Then we end up solving the resulting equation. Be careful when you have those radicals. Always reduce those radicals down to lowest terms, and if you end up with fractions, you want to divide those out and reduce them out to lowest terms. So use good algebra techniques to finish the problem. Now, let's do an example and see what we can come up with here. So I have a problem that's given to me as being 2 plus 3 as a quantity squared minus 7 equals 0. And remember, our target was that we were looking for something that looks like that very quickly. Now, if I just look at that square, the second that I saw that parentheses and the square on it, I was on the lookout. I was like, wow, if I could just get that 7 on the other side, I've got the square, and I've got a constant on the other side, life is going to be very good to me. So I can do that by just adding 7 to both sides of the equation, and I'm going to be looking at 2x plus 3 as a quantity squared equals 7. And that's exactly what I wanted to have. And now it's time to apply this square root method or square root property. And I can legally take the square root of this side as long as I'm willing to take the square root of the opposite side. Now this is my variable side over here, so I'm going to have to interject a plus and minus. I'm going to get two answers. Remember, quadratic equations always create two answers, and the second answer comes from right here. And I know when you're practicing this section, you're going to remember to put the plus or minus there because you're looking for it. But as you progress and it becomes a review exercise, remember that quadratics always have two. You'll catch yourself making a mistake of forgetting to put the plus or minus sign here. So progressing down the problem, I've got 2x plus 3 because the square root of something squared just reduces to be this. I know I've seen some people, they say this cancels. I don't really like that word, but that's what happens. Why you square rooted? Why did we square root? So we could get rid of that square and have just the inside of the body of that binomial equals plus or minus the square root of 7. Now, does anybody know what the square root of 7 is? If it reduced, you could certainly reduce it here. It doesn't reduce, so we're just going to live with that square root of 7 living there. And now I can use linear techniques to finish solving this problem. So I get 2x equals a negative 3 plus or minus the square root of 7 by subtracting 3 from both sides of the equation. And then I would divide by 2. So finishing up with dividing by 2, I will get x equals a negative 3 plus or minus the square root of 7 all over 2. Now this is my final answer, and one would argue maybe I should explicitly state it, but there's actually 2 answers here. One of them is a -3 plus the square root of 7 divided by 2, and the other one is a -3 minus the square root of 7 all over 2. One thing to be careful about here is when you have this 2 and you have these fractions, be very careful how you reduce fractions. Remember, fractions can only be reduced by factoring, and you can't reduce inside of that radical unless you've pulled the number outside as a factor as that number. So be very cautious about those kinds of things. Now, another potential view of this same problem could come about in a little bit more expanded form. Now, if you're familiar with fast factoring techniques, you should recognize this as a perfect square trinomial. Now, if you didn't recognize that as a perfect square trinomial, you might try to resort to that first technique of trying to solve it by factoring and moving the -81 to the other side and hoping you're able to factor it. Now, unfortunately, this one would not factor, and you'll see at the end why. But if I can identify really quickly that this is of that form, I'm able to put it in this something squared equals a number very quickly. Well, the something, the number is a -81, and the something is x plus 2, because x plus 2 is a binomial squared. Looks just like that, and now I've put it into that form very quickly. So sometimes this square root method is hiding just around the corner. We just got to see it right there. It'll make things much quicker for us. Now I can take the square root of both sides as long as I put a plus or minus on the right. So that turns into x plus 2 equals plus or minus. Well, what is the square root of a -81? Well, that's going to make it to be 9i. And that's okay. Imaginary numbers happen. That's why we have tools to work with them. I just need to subtract 2 from both sides of the equation, and I'll get x equals a -2 plus or minus 9i. And again, there's my 2 answers. Don't forget, always 2 answers. -2 plus 9i and a -2 minus 9i is where we're at on this problem. Thanks for joining us. We have another video in the series coming right up, and in that video we'll be talking about completing the square, which really is just a quick shortcut to make something look like square root method. We'll see you soon.